We will now take a look at a more complex setup involving a fractured object. So again, I will create it from scratch just to show you a few gotchas that you need to be aware of. So I will create a box again, dive into the geometry, and I will add a transform, just as I did on the last exercise. Bring it up a bit and rotate it. So this time I will use a Voronoi fracture just to break up the geometry. So first of all, I will scatter a few points. And probably we don't need that much points, maybe 20. Connect the points to the Voronoi fracture node. And this is probably all that we need. As usual, I will add a null object. Again, call it out, or actually out geo. And I usually like to color it black. So let's dive out of the node. And again, I will look for my rigid body tab. And this time, instead of clicking on the RBD object, I will look for the RBD fractured object, because this object has already been fractured with the Voronoi node. So first of all, let's save the file. So you can do that now. And once the file has been saved, you can control click on the RBD fractured object. So this is a very important note. Houdini will ask you if you want to create an RBD packed object or an RBD fractured object. And every single time I suggest you use the RBD packed object. The RBD fracture object is an old way of creating simulations within Houdini. RBD packed object is much more optimized and is now the standard way of creating rigid body dynamics. So click on RBD packed object. And again, we will have a new node called auto-dop network. And this node contains all that's needed to create the simulation. So let's take a look at the DOP network that has been created. So again, this setup is exactly the same as the setup we just did on the previous video. The important thing is that now with the packed object, we can create some constraints. Before we take a look into creating the constraints, let's take a look at the actual simulation. So press play. And we know the box will fall into infinity. So again, let's create a collision plane. So go into the collisions tab and look for the ground plane object. Click on the button to create a ground plane. And again, press play. So now the box is breaking into the Voronoi pieces that we just did. And although this looks interesting, normally an object wouldn't just break into individual pieces. Usually you will have some resistance and probably some pieces will break on impact and some pieces will remain attached together. And this is what constraints are for, to hold certain pieces together and be able to break only parts of the object. So let's do that now. Let me dive into the auto-dop network. Again, just to see what's happening. I'll press the L key to lay down the nodes. And this is the exact same setup that we ended up in the last exercise. So to the left is my ground plane coming through the static solver and being merged with the rigid body solver. So to create the actual constraints, let me first go back to frame 1. And again in the rigid body shelf, we will look for the glue adjacent tool. So click on the glue adjacent button, and you will be prompted to select an RBD object. So click on the cube and press enter. And you will notice that now a few nodes have been added in the AutoDOP network. So again, press L to lay out the nodes. And here you can see the glue box object, which is a constraint network. So don't worry too much about this. We will talk about how to create the network in following videos. Just note that we have not only the network, but also a glue node that is generating the properties for these connections. So let me activate the wireframe view just for us to see the connections that are being created. So these red lines are the actual constraints that will hold together the pieces. And again, let's press play to see how the simulation is looking. Notice how, although the box is falling on the ground, the pieces are now holding together and it's not breaking apart. So again, we will take a more in-depth look into constraints in later chapters. But for now, if you decrease the strength in the glue constraint node, for example, to 100, and again press play, now you will have the pieces breaking apart, and you will notice how the red lines disappear as they break. So let's see if we can achieve only a break on this corner. Let's increase to, let's say 500. It's too low. 2000 maybe. And here we have just that corner that's impacting on the ground being broken. The rest of the cube is holding together. So just before we move on, let me show you real quick what's happening in the object level. So notice there's a new geometry node called glue box object. And if you dive into that node, you will notice that here the constraints are being created. So what happens first is we're fetching the DOP object, in this case the cube, the fractured cube actually. Then we're fetching only the initial frame of the simulation. So notice how the box is static. And then we're connecting these pieces with a line that will be related to each one of the named pieces. And then a few attributes are being created here, and they are being output here again to the DOP network. So again, don't worry about how this works. We will create our own constraint network from scratch. Just notice that when you use the rigid body tools, all these nodes are created for you. So I'm going to show you, first of all, a slightly different way of creating the glue constraints, and then I will go into a very important gotcha that you may encounter using Houdini 17.5 or Houdini 18. So let me open this scene where again I have the fractured cube. Here I only have the cube with the Voronoi fracture. I don't have anything else. The DOP network hasn't been created. So last time we fractured the object here in the rigid body with the RBD fractured node. And then we glued the pieces together with the glue adjacent tool. So you can do all this in one go with the RBD glued object. So I will control click on the RBD glued object. And since the cube is already selected, the AutoDOP network will be generated. And notice how this setup is identical as the one before. So here we have the RBD packed object being fetched, and down on the bottom of the tree we have the constraint network fetching the glue constraints. So the only thing I'm missing here is the ground plane, but I can create that with the collision objects. So click on your ground plane, and again here's our ground plane object. And notice how on the object level we don't have this glue box object that was generated with the glue adjacent pieces. So let me go to the other file, and here we have 4 nodes: the ground plane, the original box, and the constraints, plus the auto-adopt network. Here we only have 3 nodes, and the constraints are being created in the same node where we had our original box. So I prefer this setup because it's cleaner. You can do it each way. It's the exact same result, just the distribution of the nodes is a bit different. But still we have the connect adjacent pieces, the attributes for these constraints, and then the output. So the result will be the same. Let me go back to my auto-adopt network. Press L to lay out the nodes. And here we go. This is the exact same setup. So if I remember correctly, we changed the glue constraint to 2000 just to have this corner break up. And there you go.